Okay, so this is what we have left for the record. Okay, we have come up to this point without the record. So let me go back and debrief this. Okay, now we have the structure with the two lateral displacements. We have to split them into two cases. In the first case, we see here is just that for the displacement on the second floor, the roof, where we want to call it, let's call it the delta one. Okay, so we restrain the another floor here, so we only have delta one here, and we assume all the from the fixed end moment that everything has to have fixed end moment equal to 6 ek delta over L. And with a quick look at this frame, we see that every member has the same similar stiffness. Okay, so that's it. So every member would have the similar fixed end moment to resist the side sway. So from the formula minus 6 ek delta over L, if I assume 6 ek delta over L equal to 6, if I begin this with minus 6 because it's counterclockwise, everything else will be minus 6. Okay, but for this, the difference is that this member AB is longer. The fixed end moment is going to be 6 ek now delta 2. This is the second case where we brace the floor here, so we have delta 2 here. So the fixed end moment is going to be 6 ek delta 2 over 6, but the rest is over 4 because of the length. So if they are going to sway with the similar amount of displacement, the shorter members will produce a more resisting moment because it's shorter. Okay, so if I assume 6 ek delta 2 over 6 for this equal to minus 6, the rest is 6 ek delta 2 over 4 because they are 4 meters long. They should produce a resisting moment 50% greater. If this is minus 6, the same member that's minus 6, the rest should be minus 9 here. And take a closer look at this two members on top. You see that the member, because now the sway is here, so that means these two members will rotate clockwise, counterclockwise, sorry. So that will result in the resisting moment now be in clockwise direction. So that's a major issue. Okay. Now we begin our distribution and we have come this far. I already forgot where I was for the delivery. So I think we have 0.52 here, right? And then we have 0.35 here. So it's going to be 0.35 for the rest. Yes, 0.35 as well. That look like 3. Where is this? Oh, we have a precision eraser already. A new feature doesn't help that much. Okay, 0.35. Okay, so I think that we're pretty much done. It's the end of the balance in the third cycle. Okay. And before we finish everything, I'm going to send this over to the fixed support. It's about 0.18. Now I can sum up everything. Okay. Let's use green. Here it's going to be 3. Oh, that's something like 3.15. That's minus 3.15. That's minus 3.6. This is 1.52. This is the end of it. Line here. It's 2.1. And here is 0.76. Okay. On the right side, it's going to be similar. Okay. So that's the first case, which is this one. Okay, the second case is just that one, I don't think I'm going to go through with that due to the time constraint. But the second one, let's show you what we are going to begin with. Okay. And I think due to the second case, that's due to the second case where we assume here, you're going to have to begin with these numbers. Okay. So that's going to be, if you want to do it, let's put the distribution factor in to make it look better. 1/3 here, 1/3 here, 1/3 here, 1/3 here. 1/3, 1/3. On top is 0.5. Ooh, it's too small. And then here is 0.5. 0.5 and 0.5. Now we begin the moment distribution by the values. That's going to be right down there. It's -6. These, right? -6, -6. This is -9, -9. But on top is going to be 9 and 9 and 9 and 9. So that's how we begin. And we carry out the same process until we have come down to number. I'm just gonna, actually, we have like 10 minutes left, but I don't think it's gonna be a good idea to go through this again. Or would you like me to go through it? It's gonna be somewhat over the time limit. Hello? Oh, we don't
maybe one circle is okay.
One circle is okay. All right. So it's a business as usual here. Okay. Let's take a look at the top joint. We have a distribution of 0.5. So yeah, we're going to use the pink one. So that is -4.5. Pretty straightforward. -4.5. This is -4.5. Minus, suppose an accident, -4.5. That's the end of the first circle, the top one. Now come to the middle joint. This one we have -6 and +9. So essentially that's +3. So it's just -1 for each. And that's 0, pretty convenient. But if you want to complete the cycle, 0, 0, and 0. How do you like that? Okay, not that big of a deal, right? And now we carry it over here. Is -2.25. Okay. Quarter. Oh boy, 1 minute. Okay. It's going to be weird if you carry out 0, right? But I don't know. It's yeah, let's do it just so that you know you have covered it. Crazy. Okay. So yeah, we carry on. It doesn't hurt to try to finish this maybe, but let me maybe do one more cycle. Okay. We have 2.25 here and then minus 0.5. So basically it's a minus 2.75. So we need about 1.38. Okay. And here we have a total of 2.25. So minus 2.25. So that means it's 3/4 each, because that's 9/4, right? And now I'm confused. Now we have 2.75 on the right. So it's going to be a little bit more. Oops. 0.92 here. That's the end of the second cycle, I suppose. We balance this, balance this, we balance this, we have balanced this. We haven't balanced that, you see. So that's it's a 1.12 and 1.12. Okay, balance that already. Balance that already, balance that already. Okay, that's like that. And we can carry out until we get the end moment, but this is like 5 minutes to time. Let me skip to that part. You can carry on. Okay, and in the end, the moment here is about 5.29, 6.81 minus 6.63. Here is you know, carry this over as well. Here is about minus 6.31. Carry this over. Try to carry as much as possible to the fixed support. This is about minus 0.17, 0.49 here. I should bring them down, right? Because that's not the summation. It's going to be misleading. $5.28 minus 5.22 52. It's slightly off. 5.50. If you do a better job, you may get a better number, I suppose. 7.92 minus 8.39. Yeah, and then that's it. Okay, so where do we go from here? Okay, one more right here, about minus 8.7. You can see one thing from this example is that the majority of the resisting moment is in the columns, not beams. Okay, but we also have a lot here as well because that's the top one. Okay, so right, from this, where do we go? We're gonna have to calculate the base shear. So from the first case, I'm gonna go over the limit a little bit, okay? So we'll try to stop the wind load here. from the first case, you have this. After all the n moments that you have from here, okay, you can calculate, and in the end, remember what we have? We braced the floor here, right? First one, after you calculate all the moment, you will know that your shear is going to be like this, 0.38, 0.57, 4.33, and then 3.38. But this because we have two displacements, so you cannot solve for the factor directly. You're going to have to combine them. So from the second case, now you have something like this. Second case where you brace here, right? Now, after the end moment, you get this 2.16, 4.27, 6.38, and then 12.81. So now, considering, I'm gonna shrink this a little bit. When we are at the first case, okay, go back out. We want the moment, okay, not the displacement. We want the moment from the load equal to 10, right? Going, say, to the left. And another, we want the moment from the load 15 going to the left. But look at what we have now. From the first case, we have 3.38 going to the right and 6.38 going to the left. So from the first case, I can say, because the first 10 is going left, so I say going left is negative. So from the load we want minus 10, now we have 3.38 going to the right. This is the first case. So it's going to be plus 3.38 x1 minus 6.38 factor number 2 equal to 0. That becomes your first equation. And then the second equation, it's a little 15 going to the left, right? So it's minus 15. And now we look at this. It's 4.33 going to the left. So it's minus 4.33 x1. And then this one is going to the right. So it's plus 12.81 x2 equal to 0. You solve these two, you get x1 equal to 14.28 and x2 is wonderfully equal to 6. Okay? After you got these two now, you bring x1 back and multiply the end moment here. And x2 multiply the end moment here and then sum them up. Then you get the answer. Rather horrible, isn't it? Yeah. Long process. Maybe I should cut you a free body diagram to show you that how we get the shear. Okay, the first one is you have what, 3.15, right? If you can recall. There, 3.15 and 3.6. It's 3.6. So that you get the first shear, right? shear here is going to be 1.69 and then 1.69. Okay. And for the second column here, you get the moment 3.15, and here is 3.6 as well, and you get the shear. And because the first case, if you can recall, they are similar, right? So you got 1.69 and then 1.69. That's 1.69, 1.69. That's why you got 3.38 then. Okay. And for this guy, you're gonna have to include the column down here as well. There is 1.52 and 0.76. Now you got the shear in this direction, 0.38, which is incidentally is that one, and this is also 0.38. And then the second column here is the same, 1.52 and 0.76. So it's again 0.30. Oh, but it's a different length, so that's why we have a different shear. It's 0.57, and that's 0.57. Okay, you sum them up. These four give you 4.33, like that. Okay, and a similar case for the second load case. I mean the second displacement case. Okay, so that's it. Any question? I have the final numbers, which I will post in our Facebook group again. Okay. But I somehow don't want to post beforehand. I just want to see that. I want you to see the procedure first, and then you see the numbers. Okay. Any question? It's pretty overwhelming, really. A little bit. Any question? Hello?
For me, no question.
Huh?
For me, no question.
Okay. Oh, so we have like, let's say Thai is gone and we have Thanawat instead. Interesting.
อาจารย์ครับพอดีผมมีคำถามแต่ว่ามันไม่ใช่คำถามในบทเรียนนะครับ
Oh, leave it then. What about?
เพราะมันเป็นคำถามกับโปรเจกต์จบอะครับ
Okay. Later then. Right. So what about you, Mr. Ryder?